Most people waste years learning because they organize it backwards. The sequence feels logical. Get instruction first, then practice. But neuroscience says that's exactly wrong. This isn't about working harder or finding more willpower. It's about reorganizing the order itself and understanding why your brain actually learns. In walking you through a different model today, one that flips the entire learning architecture. In a few minutes, I'll show you the exact moment when practice stops being punishment and becomes the instruction itself. But the last part changes everything, and it's what separates people who build real capability from those who collect certificate. If you're someone who invests in getting better at your work, this matters. Most professionals spend between 500 and 2,000 hours on a new skill and still feel shaky, not because they lack discipline, but because the learning structure itself is broken. Here's the problem: your brain wasn't designed to absorb information passively. It was designed to solve problems. When you watch a tutorial, your brain enters receive mode, which feels productive but produces almost nothing. Studies suggest we retain roughly 10% of what we passively consume. That's not a failure of effort, that's a failure of structure. But when you attempt something without full understanding first, something shifts. Your brain enters puzzle mode. It starts hunting for patterns. It connects new information to problems you're actually trying to solve. Retention jumps to 70, 80, sometimes 90%. The difference isn't the person, it's the sequence. Most people delay practice because they're waiting to understand first. This waiting period stretches a week, becomes a month becomes never. Meanwhile, the person who just started, who's fumbling through without the tutorial, is already past 3 failed attempts, which means their brain has already encoded 15 times more than the person still planning. Now, here's the twist. The people who learn fastest aren't the smartest. They're the ones who got comfortable being confused. They're the ones who treated confusion not as a sign they should go back to the tutorial, but as evidence they were asking the right question. Professionals often tell themselves they don't have time to learn new skills the right way. So they download a course, bookmark it, and never open it again. The friction isn't capability. It's structure. You can fix this, and it takes less time than you think. Here's how the system actually works, and in a minute, I'll show you the framework that changes everything. The architecture has 5 parts, and they compound. The first one is about radical scarcity. Most people approach learning like they're shopping at an all-you-can-eat buffet. They bookmark 17 resources. They subscribe to 5 different instructors. They create a learning folder with 400 links. This creates a hidden problem: decision paralysis. Before you can practice, you have to choose what to practice from. That choice is a friction point that masquerades as research. The fastest learners do the opposite. They use what we can call input narrowing. This means identifying your one best resource, or at most 3, and committing to those alone. For a software developer learning a new framework, this might be 1 official documentation site, 1 video series, and 1 community forum. That's it. For a musician learning jazz improvisation, this might be 1 pedagogical book, 1 instructor's video library, and 1 transcription database. Nothing else. This isn't laziness. This is scarcity as a forcing function. When options disappear, decision-making becomes automatic, and time previously spent choosing now transfers to doing. A startup founder recently rebuilt their entire sales approach from scratch. Instead of downloading every course on persuasion, they picked 1 book, 1 mentor, and 1 case study archive. They committed to cycling through those 3 resources twice, then practiced timeframes 6 weeks. Previous similar self-directed learning had taken 8 months. The difference: they eliminated the research phase entirely. Results vary. The second part is chunking. This is where most learning systems fail. In the design phase, people try to learn Python programming or landscape photography as 1 unified block. But that's not how skills actually transfer. Your brain needs smaller, neurologically distinct missions. A mission is a single, completable objective that takes 10 to 30 minutes. 1 mission might be use a for loop to iterate through a list of numbers and print each one, not understand Python, just that 1 specific pattern. 1 mission might be photograph the same scene at 3 different times of day. And notice how shadow direction changes. Not photography mastery, just that 1 observation. This sounds trivial until you measure it. People who chunk their practice into 10-mission sessions report retention rates 3 times higher than those who try to get better at the skill in unstructured blocks. The reason is, your brain consolidates learning during rest periods by creating natural stopping points. You're creating natural consolidation opportunity. A property manager learning commercial lease negotiation might break the skill into 15 missions. Research 3 comparable lease rates, identify 3 deal-breaker clauses, draft 1 counterproposal, and so on. Each 2-week progression includes new missions. By month 3, they're not studying negotiation, they're accumulating patterns. Results vary. The third part is what separates people who actually learn from people who think about learning. It's doing before understanding. This breaks every conventional learning instinct. Most people delay practice because they think they need context first. But context without practice is just noise. Your brain files it away as background information, not as knowledge you own. The opposite sequence produces something different. Your brain preps itself for instruction. By first trying, when you attempt a task without full knowledge, you create what researchers call productive confusion. Your brain generates predictions about what should happen. Then those predictions get tested by reality. When the tutorial arrives, your brain isn't passive, it's correcting. It's recognizing what it got wrong. It's encoding the corrected pattern with much higher fidelity than if you just watched first. This is why the best programming teachers tell students to break the code before reading the documentation. It's why the best music teachers have students attempt the piece before learning the theory. The teacher is not being cruel. They're leveraging how your brain actually works. Pay attention to this part. Most people miss this. A consultant learning presentation design might start by attempting to design a slide deck for their actual client project before watching design tutorials. They'll get it wrong. Many things will be clunky, but when they then review design principles, they're not reading abstract rules. They're debugging their own work. The retention difference is staggering. Results vary. The fourth part is explanation. This is straightforward, but almost nobody does it. After attempting, after practice, after even a small amount of competence, you teach it to someone else, or to yourself out loud, or to a wall. The specificity of the listener doesn't matter. The act of explaining does. When you explain something, you shift from retrieval to generation. Your brain has to organize disparate patterns into a coherent narrative. That process reveals where understanding is actually superficial. A design director learning new illustration software might, after 10 practice sessions, explain to a junior designer exactly how they'd approach the next project using the tools they've learned. The moment they hit something they don't fully understand, they can feel it. That's where real learning happens, in the gap between what you thought you knew and what you actually know. Most learning stops at practice. The people who skip this step plateau. The people who add explanation keep climbing. Results vary. The fifth part is where most systems completely break down. It's the architecture of repetition. People understand spaced repetition, intellectual. They don't implement it. Instead, they practice intensively for 2 weeks, then stop, then cram before a deadline. This is the most expensive learning pattern that exists. What actually works is daily, 10-minute revisits, but starting immediately the next day. Not after 1 week, not after 2 weeks. Tomorrow, this resets the consolidation cycle and prevents decay. Someone learning sales frameworks might spend 15 minutes on Monday attempting a pitch, Tuesday explaining it to a colleague, Wednesday reviewing the framework notes, Thursday attempting it again, Friday explaining what improved. By week 3, the framework isn't something they studied, it's something they own. The people who get fastest aren't the ones with the most raw practice time. They're the ones who are most consistent about touching the skill every single day. Most people miss this because it's the opposite of how cramming works. Your instinct says, practice hard, then stop, then come back later. The actual science says touch it daily, in small doses, and watch it compound. This is where it gets real. Most people quit before this phase because it doesn't feel like real learning. It feels like review, it feels redundant, so they stop. The people who push through, who touch the skill every day, even when it feels repetitive, they're the ones who build actual capability. Here's why this matters in system-level terms. Learning isn't a transfer of information, it's a rewiring of patterns. That rewiring requires consistency, not intensity. You can spend 40 hours in a weekend seminar and retain almost nothing. Or you can spend 40 hours across 4 months, 10 minutes a day, and own the skill for life. The difference isn't effort, it's repetition architecture. Now here's the part that changes everything. These 5 elements don't work individually. They work because they stack. Input narrowing cuts decision fatigue, so you have energy for doing. Chunking makes doing feel possible, instead of overwhelming doing. Before understanding primes your brain for instruction. Explanation consolidates what practice produced. Daily repetition locks it in. Each one removes a different friction point. Together, they create a system that feels almost effortless compared to the traditional approach. Most people experience learning as punishment, grinding through courses, fighting against attention, forgetting 80% by Thursday. The people using this system experience learning as curiosity being answered, almost immediately in the service of something they're trying to build. The best part is that this isn't new. It's how masters have always learned, before universities turned learning into a credentialing mill. Musicians learn by playing, not by studying theory first. Athletes learn by competing, not by reading about training. Chefs learn by cooking, not by reading recipe. We accidentally created this understand first, then do sequence for institutional reasons. It's easier to assess, easier to measure, easier to scale, but it's not how your brain works. The system works across almost every domain. A financial analyst learning Python for data analysis uses the same 5-element structure as a photographer learning a new editing suite. A manager learning to conduct better one-on-ones uses the same structure as someone learning to write screenplays. The domain doesn't matter, the architecture does. Here's a concrete example to make this tangible. Say you're a business operations manager and you want to learn grant writing because your nonprofit needs funding. Using the old model, you'd take an 8-week course, complete modules on foundation types, read case studies, maybe write practice proposals in week 6, finish the course, and 3 months later, forget most of it. Using this system, here's what changes. Day 1, you identify 3 resources, 1 grant writing book, 1 nonprofit's collection of successful proposals, 1 consultant's framework guide. That's it. You commit to cycling through those 3. Day 2, you break grant writing into chunks, read a successful grant, and identify the 3 core persuasive moves. Attempt to write a 2-paragraph funding needs section. For your organization's actual project, review your draft against 3 examples. Each chunks
with is 20-30 minutes. By day 5,
you've attempted writing before you've consumed much instruction. By day 10, you're explaining your approach to a colleague and discovering what you actually don't understand yet. By day 20, you're touching the skill every single day, even if it's just reviewing 1 paragraph from a successful grant and noting why it works. By week 6, you're not trying to learn grant writing, you're actually doing it in service of something real. The timeline is similar, but the retention and capability are dramatically different. Results vary. The mechanism works because of how your prefrontal cortex actually handles novelty. New skills require active attention. Most people assume this means they need to consume a lot of information. But attention is a limited resource. The people who conserve it, by narrowing input, chunking practice, and committing to doing, they have more attention available for actual learning. The people who consume tons of information, getting educated, they exhaust attention on sorting, deciding, and passively receiving. By the time they actually practice, their attention is depleted. Most professionals report learning faster when they have less freedom, not more. This seems counterintuitive, but it's because constraint forces focus. 3 resources instead of 30. 1 chunk at a time, instead of trying to learn everything. Doing, instead of preparing. Explaining, instead of hiding what you don't know. Daily practice instead of binge and quit cycles. Every constraint removes a decision point. Every decision point removed returns attention to the actual skill. This is the last piece, and it matters more than the mechanics, the psychology of being a beginner. Most professionals enter learning situations carrying decades of competence in other domains. Then they become a beginner, which feels like failure. The best learners in any domain aren't the ones with the highest IQ. They're the ones with the highest tolerance for being bad at something. And they cultivate that tolerance by practicing being bad, frequently in small bounded ways. That's what chunking does. It makes being bad a daily, manageable, even expected part of the process. Instead of avoiding practice because you're not ready, you practice because the practice is so bounded that not being ready is the whole point. An executive learning to write clear emails might practice writing 1 email per day for 60 days. Day 1, they'll be terrible. Day 30, they'll be noticeably better. Day 60, it's a real skill. But they had to be willing to send the first 20 terrible emails. Most people aren't. They wait for the training to make them good first, but that's not how capability develops. So let's connect this. The 5 elements work because they align with how your brain actually processes novelty. Narrowing input prevents overwhelm. Chunking prevents demoralization. Doing first prevents avoidance. Explaining forces consolidation. Daily repetition prevents forgetting. Together, they create a learning environment where you're not fighting your own neurology. You're working with it. This is how people who seem to learn fast actually operate. They're not smarter, they're structured better. The structure feels almost invisible when it's working, which is why most people don't notice it. They just look at the outcome and assume the person is gifted. But if you were to trace their learning process, you'd see these 5 elements almost every time. It's not magic, it's system design. Here's what this means practically. If you're committed to building a new capability, you don't need more time or more talent. You need to organize your learning differently. Start small. Pick 1 skill, apply the 5-element system. Notice what changes in your retention, your speed, and your actual capability. Most people who try this report being shocked at how much faster it is. Not because they're trying harder, because they're structured better. The best part, once you see how this works, you can rebuild any learning process you're undertaking. 3 core insights emerge from understanding this system. First, structure beats intensity. Second, doing builds understanding faster than understanding builds doing. Third, daily consistency outpaces any single heroic effort. If you're building a capability that matters to your career or craft, start with input narrowing tomorrow. Pick your 3 resources, stop looking, and begin.